that the same person with the same role and job title could actually be different actors at different times. The focus should really be on the goal that the actor wants to accomplish. And how we define those actors can vary depending on the use case. For example, in a use case for heating meals, I would expect all of the different astronauts on the spaceship to use the system in the same way, to prepare a package of food. And the people back on Earth mission control and the nutritionist are simply monitoring that activity way to prepare a package of food. And the people back on Earth, mission control and the nutritionist are simply monitoring that activity. In this scenario, there isn't a difference between the onboard astronauts. They all have the same goal. So this situation really comes down to somebody preparing a meal and someone monitoring it. So it might make sense to phrase the actors for this use case as the cook and the monitor. Not a job title or specific role, but a perfectly acceptable name for the actors who take part in this particular use case.
Hold on a sec. Use cases always have a single primary actor and possibly one or more secondary actors, if required. So who's the primary, the cook or the monitor?
Well, when writing use cases, the primary actors aren't necessarily the most important actor in the scenario. They're just the one who initiated it. So in this situation, the primary actor would be the cook, and the monitors would be the secondary actors. Before you dive headfirst into writing use cases, it's good to spend a few minutes brainstorming possible actors. You're looking for anything that lives outside of your application but interacts with it to accomplish some goal.
Sometimes identifying the actors is straightforward. If we were building a simple single-player video game, then there could be just one actor, the player.
However, something like the space microwave that we're designing could have multiple people interacting with it to accomplish different goals. Thinking about their different job titles or departments can also prompt ideas for use case scenarios. As we're brainstorming, we'll use stick figures to represent each of the possible human actors for our application.
Well, the spaceship will have several astronauts on board that need to use the space microwave to eat: the mission commander, the pilot, and the flight engineer. And back on Earth, mission control will want to monitor the status of the equipment, and I'm sure the astronauts will have nutritionists keeping an eye on what they eat.
Now, in addition to identifying people, you should also ask, does the application need to interact with other computer systems or other organizations? Those external systems are considered actors too.
Since we have a requirement to notify astronauts when their meal is ready via space pager, the microwave will need to interface with some sort of space pager system. But we don't know what that system will be yet or what the interface to it will even look like.
And that's okay. For now, all we're doing is identifying actors as a starting point, which should be painless and straightforward. We can represent that external pager service, whatever it ends up being, as a box over on the right side, and we'll draw a line to show that it interfaces with our system. As we get further along in the implementation details, we may learn that this one box should actually be several different external systems that the microwave needs to interface with. And if so, we'll just update our collection of actors and use cases accordingly. Now, looking at our list, most of the human actors we've identified are all based on roles or job titles. But keep in mind that the same person with the same role and job title could actually be different actors at different times. The focus should really be on the goal that the actor wants to accomplish, and how we define those actors can vary depending on the use case. For example, in a use case for heating meals, I would expect all of the different astronauts on the spaceship to use the system in the same way, to prepare a package of food. And the people back on Earth, mission control and the nutritionist, are simply monitoring that activity. In this scenario, there isn't a difference between the onboard astronauts. They all have the same goal. So the situation really comes down to somebody preparing a meal and someone monitoring it. So it might make sense to phrase the actors for this use case as the cook and the monitor. Not a job title or specific role, but a perfectly acceptable name for the actors who take part in this particular use case.
Hold on a sec. Use cases always have a single primary actor and possibly one or more secondary actors, if required. So, who's the primary here? The cook or the monitor?
Well, when writing use cases, the primary actors aren't necessarily the most important actor in the scenario. They're just the one who initiated it. So in this situation, the primary When writing use case scenarios, describe a goal that an actor can accomplish in a single encounter and stay focused When writing use case scenarios, describe a goal that an actor can accomplish in a single encounter and stay focused on the user's intention, what they really want to accomplish.
So, something like turning on the microwave.
Well, at first, turn on microwave might sound like a good use case. After all, it has an active verb phrase, and it could have multiple steps and conditions. But if we emphasize the user's intent, their goal. Their goal isn't to turn on the microwave. The reason they want to turn it on is to do something. So what is that something?
Well, they probably just want to cook a meal.
Bingo! Cook meal. Generate reports. Change settings. Order supplies. These are user-focused goals, each with several steps that can be accomplished in one encounter. Turning on the microwave might be a part of one of these use cases, but it's not a use case by itself. On the other side of the spectrum, a goal on the level of feed entire crew or execute mission might be too broad. Those would involve multiple encounters with whatever application is being used.
But I've seen some pretty broad use cases from developers.
True, some people define these broader and smaller use cases as a way of tying things together. But at least initially, you want to focus on the use cases that capture the user's true goal, emphasizing the goal of one encounter. Now, a simple casual use case can have multiple scenarios. You should focus on the main successful scenario. The day use case when everything goes right. But when necessary, you can describe the alternate paths or extensions.
Like when the microwave can't identify the meal packet that's put in it.
Yep.
Or when the astronaut tries to shove too many meal packets in all at once.
Bingo.
Like when a random cosmic ray strikes the microwave and heats the food packages too fast and they all explode.
Too far. You're not trying to envision all the bizarrely unlikely but technically possible events. Just focus on the typical situation that would occur, what you'd want to do with those situations. Now, you could write these as paragraphs or numbered steps. The goal is readability and ease of creation over formality. When you're writing, use an active voice. Omit needless words and needless detail. It's very common to see sentences phrased like, the system is provided with the meal packaged by the astronaut. But you could just as easily say, astronaut inserts meal package. Active voice, easy to read, short and concise. Another common thing you may see, particularly from programmers, is too much detail or the start of describing the implementation. So, the system connects to the external pager system over HTTPS and uses JSON to format the text message to be transmitted, then waits for a delegated callback response. The goal here isn't to write pseudocode. It's way too much. For a use case, system sends pager message would be perfectly fine. Another thing that's tempting to describe but doesn't belong in use cases is a user interface. You should describe the scenario without using words like screen, click, button, select. None of that. There's no user press the start button. Focus on the intention. The layout of the user interface will follow the function of the application and what it needs to do.
After you've come up with your first set of use cases, how do you know if you've missed anything?
Well, you can never know for sure, but questions that may prompt a new goal or actor are, who does system administration? If this is a system that needs to be started and stopped, or backed up on weekends, or have software updates applied, who does that? And how do they interact with the application? Who manages users and security, particularly if you have role-based actors? What happens if the system fails? While the person who reacts to this may not be a classic user, they're certainly an actor. And is anyone looking at performance metrics or system activity logs? These questions will often prompt a couple of fairly obvious actors for the application. These questions will often prompt a couple of fairly obvious actors for the application, particularly if it's being developed for internal use. After hashing out the feature-focused requirements that say what the system subject, with terrific examples subject, with terrific examples the use cases may evolve or change. If you don't have all the information at this point. And you may have to make some assumptions if you don't have all the information at this point, and that's okay. The use cases may evolve or change. cases in any iteration of a project. As a rule of thumb, you shouldn't spend more than a few days working on use cases in any iteration of a project. As a rule of thumb, you shouldn't spend more than a few days working on use cases in any iteration of a project. Get them done so you can There isn't a single right way to write use cases, and they can be written as but at the very least, a use but at the very least, a use case needs three essential things. But at the very least, a use case needs three essential things: a title that describes a goal, the person who will interact with the application to achieve that goal, is separate distinct. Both of those examples could be separate use cases, separate distinct goals for the application. Entity that acts on the system is an actor, including other computer systems.
Program.
Not just humans, any external entity that acts The aim is to write this so it's short and succinct, using everyday, non-technical secondary actors, stakeholders, and so on. Or departments can also prompt ideas for use case scenarios. When writing use case scenarios, describe on the other side of the spectrum, a goal on the level of On the other side of the spectrum, turning on the microwave might be a part of one of these use cases, but it's not a use case by itself. On the other side of the spectrum, a goal on the level of feed entire crew or execute The use case diagram is another diagram that comes from UML, but the name can be The use case diagram is another diagram that comes from UML, but the name can be a bit misleading. It sounds like a diagram of a use case, but in actuality, it's a diagram of several use cases and multiple actors at the same time. It shows the relationship between the actors and the different use cases in which they're involved. Now, this is not a substitution for written use cases. We definitely still need those. Use case diagrams and written use cases are two distinct products that show different perspectives and complement one another.
We finished brainstorming the actors and wrote a few casual use cases, so I think we're ready to draw our first use case diagram.
Agreed. And since I can't draw while I've been talking, I'm giving you the markers. Start by listing out the use cases. Heat meal, generate reports, change settings. These aren't in any particular order, and I'm not trying to be exhaustive. Just listing a few use cases that make sense. For the actors, let's say they're all role-based. And for now, we're keeping it simple. Let's say they're all role-based. And for now, we're keeping it simple with just an astronaut and the nutritionist back on Earth. And since those are all human actors, we'll represent them as stick figures. Stick figures are perfect because they're easy. Easy on paper, easy on the whiteboard. This doesn't need to look impressive. And just as we show actors with stick figures, draw ellipses around the use case titles to make it obvious they're self-contained use cases and not just a piece of text. Now draw a box around all the use cases to represent the boundaries of the system. Anything inside of the box is part of the application we're trying to write, and everything that's not is outside. Next, draw a line between any of the actors and the use cases they will interact with. An astronaut can heat up a meal, so draw a line from the astronaut to that use case. The astronaut might want to generate a report to see what they've been eating, and their nutritionist will want to do the same. And finally, the nutritionist may want to tweak the microwave cook settings to make sure the astronauts are getting the best meals possible. These lines don't need arrows because they're not about direction. They're merely saying which actors use which use case. Now, part of the use case to heat a meal needs to interface with a separate external space pager system to notify the astronaut when their food is ready. Now, part of the use case to heat a meal needs to interface with a separate external space pager system to notify the astronaut when their food is ready. We could use a stick figure, but since it's a non-human actor, I prefer to use a box instead. Draw it over on the right side and write the word actor with 2 angle quotes to make it obvious what it is. And finally, connect the line between the external system and the heat meal use case that interacts with it. It's common to put the primary actors on the left-hand side. Those are the ones that initiate any of the use cases. And the secondary actors on the right-hand side, the actors that take more of a reactive role, but even then that's not a hard and fast rule. Also, this diagram is not referring to a specific sequence that the use cases need to be executed in, so there's no order that they need to be listed. It's meant to be a simple overview of the relationships between multiple use cases and multiple actors at the same time, without the details of each particular written use case. It can be useful as a communication tool, even with business users, because it's not particularly technical. It can be helpful to figure out if something is missing from the picture. User stories are another written format for describing User stories are another written format for describing parts of an application. But they're shorter and simpler than a use case. A user story still describes a single, small scenario from a user's perspective, focusing on their goal, what they want to do, and why, rather than focusing on the system. But unlike a use case, which can be several pages, a user story is typically written as just one, perhaps two sentences, and they're very commonly written on index cards because that forces us to keep them short and sweet. Even though they're concise, user stories generally follow a format that looks something like this. As a type of user or role, I want, here you describe the goal, so that, the reason or the benefit. The final part, the so that, is optional, but it's very useful to provide context of how this application will be used.
Here's one for you. As an astronaut, I want to heat up my food so that I can eat a warm meal.
Great! It focuses on one specific goal of one specific user for a particular reason. The idea is that you can quickly brainstorm a lot of user stories, even unique ones.
How about, as a nutritionist, I want to see what astronauts eat so that I can monitor their diet.
Perfect! Let's make the nutritionist's job easier. Just as when writing use cases, the focus is on intent and should not include descriptions of the user interface.
So, as an astronaut, I want to press a button to delay when my food gets cooked so that it will be ready later. Would be a bad user story?
Right. Leave the user interface out of it. It would be better to say, as an astronaut, I want to schedule when to heat my food so it would be ready later. That leaves flexibility for how we implement it. Also, avoid detailing alternate paths or exceptions or listing any technical information in user stories. These are intended to be quick, readable summaries of a specific goal and why the user wants it. They can be done very early on, often right at the start of a project, and they serve as a placeholder for deeper conversations that you need to have.
These user stories sound an awful lot like they're just short use cases.
It can seem like that at first, but use cases and user stories really are different things. The most obvious difference is the format, but they also serve different purposes. A user story acts as a placeholder for a conversation. A reminder that we need to get deeper into the details of something. A use case, on the other hand, can be regarded as a record of a conversation that has already happened, detailing the steps of how a particular goal may or may not be achieved. Now, certain software development methodologies may favor one of these over the other, but use cases and user stories are not direct competitors. Nor are they necessarily a replacement for writing functional requirements. These are all different tools in your toolbox. Depending on the development methodology you're using, you're likely to use some combination of requirements, use cases, and user stories, but not necessarily all three. And the order in which you create them can vary. However you do it, describing your system in plain language is incredibly useful to identify why we're building this application, and those descriptions serve as input for the next stages of the analysis and design process. If you want to learn more about the concise user story format, check out Mike Cohn's book, User Stories Applied for Agile Software Development. If you want to learn more about the concise user story format, check out Mike Cohn's book, User Stories Applied for Agile Software Development. It's a book you're likely to see recommended if you use a process like Scrum or Extreme Programming. It's time for another challenge. The use case diagram is another diagram that comes from UML, but the name can be a bit misleading. It sounds like a diagram of a use case, but in actuality, it's a diagram. Now, this is not a substitution for written use cases. We definitely still need those. They're merely saying which actors use which use case. Now, part of the use case to heat a meal needs to interface with a separate external space pager system to notify the astronaut when their food is ready. It's meant to be a simple overview of the relationships. User stories are another written format for describing parts of an app. It's time for another challenge. This time, you'll be writing use cases and user stories to help design a jukebox to go into a spaceship. It's time for another challenge. This time, you'll be writing use cases and user stories to help design a jukebox to go into a spaceship so astronauts can listen to music on their way to the moon. This is an extension of the previous challenge problem where we defined requirements for the space jukebox. If you completed that challenge, then you can use the requirements that you defined as a basis for this challenge problem. Otherwise, feel free to build on our partial set of requirements shown here. Your goal for this challenge is to write at least 2 use cases and 2 user stories for the jukebox. But if you're feeling inspired, you can certainly write more for extra practice. I'll leave the format and level of detail for the use cases up to you. You can write the scenarios as a paragraph or a list of steps. Either one is fine. This is an open-ended challenge with a wide range of possible solutions, so take some time to think it through. And when you're done, be sure to watch our solution video to see how we approach the problem. To develop our use cases and user stories for the jukebox challenge, we decided to start with the most common thing you can do with the jukebox.
Play a song.
The primary actor here will be the user, and I decided to format the scenario for this use case as a paragraph. So the system identifies the user. The user browses the library of available albums. They select an album, then browse the songs on that album, and then finally, the user selects a song and a jukebox plays it. This may seem like an obvious sequence of events, but taking the time to actually put it down in writing now will make later parts of the design process a lot easier.
For the next use case, let's look at a slightly more complicated scenario, selecting multiple songs to play. I prefer to format my use cases as a list of steps. The first 4 steps of this use case will have a lot in common with Olivia's use case to play a single song. The system identifies the user browses the available albums and songs, selects a song, and then the system begins playing it. After that, though, this use case introduces some new events. The user continues browsing and selects a second song. The system adds that second song to a play queue and then plays it after the first song is over. This use case introduces the concept of a play queue that wasn't present in the first one.
Now for some user stories. If Baron has gone and filled up the play queue with his music, then, as a user, I want my song to be added to the front of the long play queue so that I don't have to wait hours to hear it.
And from a usability standpoint, as a user, I want to be identified without having to touch anything, so I can use my hands to do other things. Coming up with user stories is usually a lot quicker than writing use cases, so it's easy to keep pumping them out. As a user, I want to sort and browse songs by artist so that I can listen to every song by ABBA.
That will drive the other astronauts crazy. So, as the spaceship's commander, I want the ability to cancel other user selections so I don't have to listen to disco all the way to the moon. Now, the prior set of requirements we came up with for the space jukebox didn't mention anything about a commander or administrator. But based on that last user story, I think that's something we'll need to include. And that's one of the reasons why just the process of writing use cases and user stories is valuable. It can help uncover new requirements.
After defining requirements and after defining requirements and writing some use cases or user stories, we start to transition from analysis, understanding the problem we're trying to solve, to design, how we're going to organize our solution. And I think a good context for explaining that is the design of a video game. Olivia and I are game developers, and I have a brand new idea for a game. Get this. You're a spaceship, and you shoot missiles at astronauts asteroids that are trying to crash into you.
That feels oddly familiar. What if instead you're the asteroid and you smash into the spaceships that are trying to blow you up?
That is genius. That's why I married you.
Good, because I write down the analysis and written up the use cases.
Well, with the analysis done, our next step is to create a conceptual model. That may sound complex, but a conceptual model simply identifies the most important objects in the application and the relationship between them. Now, I'm using the word object loosely here. We're not worried about software objects quite yet, but more generically, what are the things in the application that we need to be aware of? Not everything we pick here will become a class, but a lot of them will.
To identify objects, we'll go through all of our use cases and user stories and any other written requirements to pick out all of the nouns.
That's one benefit of actually writing out all those descriptions.
I'll start with this use case that describes the player's asteroid dodging a missile. For one of the spaceships by simply highlighting and underlining all of the nouns. The system spawns enemy spaceship in play area. Spaceship flies towards player asteroid and fires missile at it. Player steers asteroid in direction to avoid missile path. Missile flies past player asteroid and disappears off screen. As I'm gathering a list of potential nouns, I fight the urge to analyze or judge the words. I don't worry if there's a better word to use, or if perhaps we used a different noun to describe it elsewhere.
And if you miss one, don't worry, it happens. Now we can take a first pass through our list and find if there are any obvious duplicates.
Well, in this use case, the word it refers to the asteroid, so that's an easy one to remove.
You'll often find yourself combining some of these or even splitting them up. Picking out the nouns is merely a starting point, and you'll find that sometimes attributes start to announce themselves.
The word off-screen is really part of the concept of area, so off-screen might be an attribute of an area class, depending on how things get organized. But we're not focused on showing that kind of data now, so I'll remove it. Now, to me, the noun direction feels questionable here. Direction is where something goes, but should it really be an object?
At this point, if you're in doubt, keep it. We could implement the asteroid's direction as an attribute with simple values to represent its velocity in each axis, and in that case, we wouldn't need a separate class for direction. On the other hand, if that direction of travel might need to be translated between different coordinate systems, then encapsulating that behavior in a direction class could be useful. We aren't that far into the design process, so we don't know yet. Let's keep it because we can always make changes later. One last item to remove. Even though system was used as a noun, let's remove it here, and we'll explain the reason why a little later on. So that leaves us with a handful of nouns from this one casual use case. These are just even though system was used as a noun, let's remove it here, and we'll explain the reason why a little later on. So that leaves us with a handful of nouns from this one casual use case. These are just the names of potential objects, and by simply drawing a box around each of those objects, we have the beginning of a conceptual model. Once we have the potential objects picked out for our conceptual model, it's useful to indicate the main relationships or associations between those concepts by drawing lines between the boxes. And since I drew the last diagram, it's your turn to take the marker.
Fine.
And since I drew the last diagram, it's your turn to take the marker.
Fine.
Many of these relationships will be obvious, but we can always reference our written use cases and user stories if needed. I know that the idea or concept of a player has some kind of relationship or interaction with the asteroid, so draw a line between those boxes. The asteroid exists within the area, so that's another relationship. And the spaceship and missile also exist within the area. There's a relationship between the spaceship and the missile, as well as the missile and the path it follows. And though I'm not completely convinced it should be an object, the asteroid and spaceship both travel in a direction. Now, optionally, it may be useful to add a short note to actually describe the relationship. It could be something as simple as the word uses, as in the spaceship uses the missile, or even better, spaceship fires missile, because that's more specific. So rather than saying the player uses the asteroid, we could say the player steers the asteroid. The area also contains spaceships, and the missile follows a path. Finally, we can add some optional symbols to describe a bit more about those relationships. For example, the game area can contain multiple spaceships, and we can describe that using the UML notation for multiplicity, representing one or more of something. This additional notation isn't necessary, but it can be useful. The key question should be, is it interesting or important enough to need to be put on the diagram? Now, it may seem like there are a lot of interesting details missing from here, and there's no way we could start writing code based on this diagram. But that's okay. This is just a conceptual model to use for communication and to prompt ideas. The benefit of detailing these relationships is that it makes it easier to realize which objects interact with each other, meaning which objects have behaviors that affect other objects. We need to figure out the responsibilities for our conceptual objects to really identify what are and what are not classes that we'll need to create. And just as we started by picking out nouns in our written description to create a list of potential objects, we need to figure out the responsibilities for our conceptual objects to really identify what are and what are not classes that we'll need to create. And just as we started by picking out nouns in our written description to create a list of potential objects, we can go back to the use cases and user stories to look for verbs and verb phrases to identify responsibilities.
Looking at our use case for dodging a missile, we have phrases related to the spaceship like looking at our use case for dodging a missile, we have phrases related to the spaceship like spawns enemy spaceship, flies towards player, and fires missile. The player steers asteroid to avoid missile, and the missile flies past player and disappears off screen. Now, not all of these will necessarily become behaviors. Some might need to be combined, some might need to be split apart, and some may not be needed at all or will be replaced by something else. But they're a good starting point and will often prompt other discussions.
Something that isn't always obvious is where these responsibilities belong, particularly if they affect different objects. Since our use case here has an active perspective, it's oriented around what initiates a behavior, not necessarily whose responsibility it is to perform that behavior. When asking the question of where should a behavior live or whose responsibility is it, remember that an object should be responsible for its. When asking the question of where should a behavior live or whose responsibility is it, remember that an object should be responsible for itself.
So, for example, the idea of steering the asteroid, it's pretty obvious what that means and that it's going to be initiated by the player. But even though it's the player that wants to steer the asteroid, I shouldn't write code in the player class to directly change the inner state of an asteroid object. The player should really ask that of the asteroid object. The player should tell the asteroid where it wants to go, but the asteroid is responsible for actually changing its state to move there.
Figuring out whose job it is to do all of these things can be tricky. So let's take a pass through the list of verb phrases from our use case and make an initial attempt at distributing them amongst the conceptual objects. starting with the phrase spawn enemy spaceship. Although the game system will initiate that happening, the spaceship object should be responsible for creating itself and establishing its location within the play area. The next phrase, flies towards player, is an action for that spaceship, and I'm going to rephrase that to simply move. Next on the list, a spaceship initiates firing a missile, but a missile object should be responsible for spawning itself, knowing where it's going and what it's doing. And when it comes to the player steering the asteroid should handle moving itself. Now, the next one is a bit tricky. Avoid missile path. What that really means is that we need to detect if and when a missile collides with the asteroid. So we could give that responsibility of detecting a collision with the asteroid to the missile, but we could also put the responsibility of detecting collisions under the asteroid. Either way could work, and at this point it may not be clear which is better, or if it even matters. Either way could work, and at this point it may not be clear which is better, or if it even matters. For now, I'll leave the responsibility to detect collisions with the asteroid because I'll need to know when it collides with other things like a spaceship for other use cases. Now, for the last two items on the list, flies past player can be simplified to moving the missile, and for the missile to disappear when it goes off screen, it will need to detect when it goes out of bounds. There are always multiple successful ways to implement ideas in object-oriented programming, and even this simple model could have been arranged in several different ways.
You gave a couple responsibilities to the asteroid, the spaceship, and the missile, but the player didn't get any. Shouldn't the player get some responsibilities because, they're playing the game?
Not necessarily. Keep in mind that this isn't showing who initiates these actions, but where the responsibility lies in performing them. Not necessarily. Keep in mind that this isn't showing who initiates these actions, but where the responsibility lies in performing them. The player is still going to cause things to happen by requesting behaviors of other objects. It's a common mistake for new developers to give way too much behavior to a single actor, such as the player, because the player's what drives the encounter. In object-oriented design, an object that knows too much or does too much is often called a God object.
Along those lines, an issue that often comes up is creating a system object and putting a huge amount of responsibility in it. It happens when people see phrases like system spawns spaceship and system detects missile collision. Recognize the phrases like system reduces player life counter really means that some part of the system reduces the life counter. Some part of the system spawns a new player asteroid. So while there's often a built-in system or application object included in many object-oriented programming languages, if your own design contains a central system or master object that's filled with lots of unrelated behaviors and just seems to exist to control everything else around it, that's a clue that you're still thinking like a procedural programmer. Responsibilities should be distributed between your objects, not stored in one master object. An object should be responsible for itself as much as possible. They'll make maintaining and updating the application much easier in the future.
One technique that can be useful during this stage of object-oriented design are CRC cards. One technique that can be useful during this stage of object-oriented design are CRC cards, which stands for Class, Responsibility, Collaboration. CRC cards contain the same information as the conceptual object diagram, just in a different format. They're drawn on index cards, and they're meant to be simple, easy to create, hand around, discuss, spread out on a conference table. And you dispose of it if you make a mistake or change your mind. Each CRC card represents one class, and it has 3 sections. The first C is the name of the class at the top, which is usually underlined. The R is the responsibilities of the class, the things that it